I'm going to take unit 2 now. Unit 2, vector calculus. So vector calculus. Under this, we have some basic definitions like vector point function. Second one is scalar point function. So what do you mean by vector point function? A function which has both magnitude, which involves both magnitude and direction. Example, velocity. Second one is scalar point function, which involves one and only magnitude. Example, I can find temperature of any plate or body like that, magnitude, which contains one and only magnitude. This is a very basic function which is very important. Next one is gradient. So what do you mean by gradient? Gradient, I'll give the formula now. Rate of change of your respective function. So rate of change of your respective function f of x, y, z. The function depends upon x, y, z, three variables, remember that. So gradient, del f. So del f equal to I dou f by dou x plus j dou f by dou y plus k dou f by dou z. So remember this. Next one is unit normal. Unit normal vector. When we call a vector as unit normal vector, so I'll give the formula here and then I'll explain what do you mean by unit normal vector, how does it works. So n cap equal del f by modulus del f. Where we apply this unit normal, where does it place? Like whenever we need a rotation of photons, electrons, or otherwise I can say like graphics. Okay, so it plays an important role in graphics, right? So with this information, next definition is angle. Angle, how to find the angle between two surfaces. Angle between two surfaces. Say for an example, take one sphere, the other scalar function is a cylinder. How to find the angle between the two surfaces? The first one is the scalar function phi 1c, and the second function is another scalar function, as I told you, like sphere. So the formula is this: cos theta is equal to del phi 1 dot del phi 2 divided by modulus del phi 1 dot del phi 2, right? So this is the definition I want to give you. Another important definition, so-called solenoidal. So when we say the function, the vector is solenoidal, another one is irrotational. When we say a vector is irrotational. So these are all the very important definition. When we call a vector is solenoidal, when it satisfies this condition del dot p equal to 0. Similarly, irrotational means instead of dot, cross, you have to use the formula cross. Del dot v equal to 0, which means the vector is immovable. The vector is immovable. Whenever we can, for an example, I can say whenever the fan in which it rotates, okay, not rotates, it rotates, okay. So we can call that as an example for this solenoidal and rotation. Depending upon the domain, wherever we want, we can use dot product, and wherever we want, we can use this cross product. So we have to remember these things. Now I'll go to the problem one by one. Problem 1 is this: find a unit normal vector. Find a unit normal vector for whom? Unit normal vector to the surface, to the level surface, x square y plus 2x z equal 4 at the point. So this point is very, very important, because any point, whenever we say a position vector or a point, it is nothing but any point on the space. Any point on the space, like x-axis, y-axis and z-axis. I can represent any point on the space, which is nothing but the distance from x-axis and the distance from y-axis and the distance from z-axis. So remember, that's what, everywhere the point exists. So which point, whatever we need, we have to go it accordingly. I mean, we have to do it accordingly. So in this case, they have given the point 2, x distance is 2, y distance is minus 2, and z distance is 3. So with this information, I'll go for the solution. Now, what is n cap? So n cap, as I already gave you, we have to find del phi, I mean gradient of phi, by modulus del phi. by modulus del phi. So how to find this del phi? As I told you, gradient of a vector, like del phi is nothing but I dou phi by dou x plus j dou phi by dou y. Like I'll clear you here. Del phi equal to I dou, this is our function phi. So let phi is equal to x square y plus 2xz minus 4. So this is the, what is this? This is phi. So I dou phi by dou x. So what happens dou phi by dou x? 2x, yeah, so dou phi by 2xy plus 2z plus j vector dou phi by whom? Dou y. So dou phi by dou y means I'll get x square plus z vector into dou phi by dou z. So dou phi by dou z means I'll get 2 times x. Now it is time to substitute the point. As I told you, what point? 2, minus 2 and 3 I have to substitute, and then I have to find the vector, I mean gradient of this vector. What do you mean by gradient? Rate of change of this scalar function, right? So I vector multiplied by, so your x value is whom? 2. So 2 minus 4, so minus 8 plus 2z plus 6 plus j vector into, what is x value? I mean x distance is 2. So 2 square will be 4 plus j z vector, sorry, k vector. So k vector into, this is k vector, sorry, right. So 2 into x, what is the value of x here? As I told you, x point is 2. So 2 to 4. So here comes my gradient, I mean rate of change of this phi I got, like minus 2i vector plus 4j vector plus 4k vector. Now I'll go to n cap. So what is the formula for n cap? As everyone knows, minus 2i plus 4j plus 4k whole thing divided by square root of 4 plus 16 plus 16, right? Yes, which in which I'll get minus 2y plus 4j plus 4k divided by 36. So which is nothing but, finally I'm going to get my vector, I mean that unit normal vector, which is very, very important for every graphs, constructions, for everything, which is an important one. So divided by 6. So this is the respective normal vector for this problem. So I'll go to the second problem. Second problem is what? Second problem, yes. So second problem is this. Find the directional derivative of, find the directional derivative, I'll write as dd, nothing but directional derivative of f of x comma y comma z, which is equal to x square minus 2y square plus 4z square at the point 1 comma minus 1 in the direction 2i plus j minus k vector. So solution, directional derivative, I think I didn't give the formula, but now I'll give you directional derivative. What we have to find, you know, we have to find the function del f, I mean the gradient function of f dot of n cap. Why we are using this n cap? So with respect to the respective direction, we are going to find the directional derivative. So what do you mean by directional derivative? Same thing, rate of change only we are going to find. With respect to certain direction, as I told you, in the domain, everywhere the direction moves. As I told you, the electron moves, photon moves. So everywhere it moves. With respect to what direction, we have to identify the rate of change. If you want, we can apply this concept, directional derivative, mathematically. Right, I'll go for del f. So what is del f? As usual, I dou f by dou x. So here what is f? I mean function of x comma y comma z is nothing but x square minus 2y square plus 4z square. Right. So I vector into what is dou f by dou x? So 2x, yeah. So plus j vector into minus 4y plus k vector into whom? So this is z square, right? Yeah. So z square means k vector into 2z. So dou f by dou x, I got 2x. Dou f by dou y minus 4y. Dou f by dou z, I'll get 8z. Those are 8z. Right, I got my del f. Now at what point I have to find the gradient? As I told you, 1, 1, minus 1. Okay, so at the point 1 comma minus 1, I have to find. I'll get 2i vector minus 4j vector, z value is minus 1, minus 8k vector. So I got del f now. Now before that I need n cap also. What I need n cap also. I'll come to this slide. Right, n cap. So what is n cap? What is unit? I mean, what is the direction they have given? This is the direction. Right. So like 2i plus j vector minus k vector divided by we have to find that magnitude, right? So 4 plus 1 plus 1, so which is nothing but 2i plus j vector minus k vector divided by square root of 6. Right, this is my n cap. Now I'm going to find the directional derivative. Like I already know del f, so which is nothing but 2i minus 4j minus 8k vector dot 2i plus j minus k vector divided by square root of 6. Okay, yes. So it is equal to, since dot is there, remember the product I dot I will be unity 1, I dot j will be 0, I dot k will be 0. Similarly, j dot I will be 0, j dot j will be 1, j dot k will be 0. Proceeding in that way, I'll get 2 dot 2 like 4, because I dot I it's going to be 1. Next, j dot j is going to be 1, so I'll get minus 4. Next, minus and a minus plus, so plus 8, because k dot k is 1. So divided by root 6, so 4 get cancelled. Finally, I'll get this value as my directional derivative. So this is my directional derivative. Next, I'll go to the next problem. Like find the angle between the surfaces. Already I gave the formula for angle between the two surfaces. Imagine any two surface, any scalar function, x square plus y z equal to 2. Here this is the first surface given, and second surface is x plus 2y minus z equal to 2. At what point we have to find the angle? At the point 1 comma 1 comma 1. So I have to find the point at this one. Right. Now solution, let phi 1 equal to whom? So let phi 1 equal to the first surface, x square plus yz minus 2. Second surface is phi 2, x plus 2y minus z minus 2. Now as usual, gradient, what do we want? We want angle between the two surfaces. So what is the formula for angle between the two surfaces? I have to find del phi 1 and then I have to find del phi 2. So del phi 1. So I dou phi 1 by dou x. What I'll get? 2x. Next, plus j vector, y means z, plus k vector into whom? K vector into dou phi 1 by dou z will be again y. Now what is the point? At the point of x distance, y distance is nothing but 1 comma 1 comma 1. So I'll get del phi 1 as 2i plus j vector plus k vector. So similarly, I have to find del phi 2. So what is del phi 2? I dou phi 2 by dou x, it is going to be 1 plus j vector dou phi 2 by dou y. So which is going to be 2 plus k vector into dou phi 2 by dou z, which is going to be minus 1. Right? Now, so at the point 1 comma 1 comma 1, I have to find, I'll get like I vector plus 2j vector minus k vector. Okay. Now I'll go to the formula cos theta, which is equal to del phi 1 dot del phi 2 divided by modulus del phi 1 dot modulus del phi 2. Right, which is equal to, what is del phi 1? What is del phi 1 here? Where we have this one. So like 2i vector plus j vector plus k vector dot I vector plus 2j vector minus k vector. So whole divided by square root of 4 plus 1 plus 1. So here also 1 plus 4 plus 1. Now we will do the dot product. So as I told you, I dot I is 1. The next one is 2 dot, j dot j is 1. K dot k is 1. So if we see the remaining things like I dot j will be 0, I dot k will be 0, j dot I will be 0, j dot k will be 0. Similarly, k I will be 0, k dot j will be 0, k dot k will be 1. So if that is the case, which is equal to, I'll get 2 plus 2 minus 1 divided by root 4, 5, 6, root 6 into root 6. So 4 minus 1, I'll get 3. So 3 by 6. So cos theta is equal to 1 by 2. Okay. So theta is equal to pi by 3. So this is the required angle between the two surfaces. So remember we found angle between the two surfaces. Okay. In this way, whatever may be the surfaces we are getting, we can find the surfaces. Okay. Angle between the two surfaces. Remember these concepts.